Welcome to our project demonstration session. The name of our project is Microcontroller based distance measurement using Ultrasonic Range Finder. At first, demonstrating the project, we are just going to make introduction to the apparatus of the experiment here, one by one. Here we have used a weird 80 mega 8 microcontroller and constant 5 volts supply. And here an ultrasonic range finder module HCSR04 and a 16:2 LCD display module. Now here we have used ultrasonic sound waves to measure a distance in a particular range here, that is within the range of the sensor, and the sensor works in a definite principle. Now I am going to describe the principle of the sensor here and in a brief comment. A short ultrasonic pulse is transmitted at time 0 and reflected by an object. The sensor then receives this signal and converts it into an electrical signal. The next pulse can be transmitted when the echo is faded away. The time period is called cycle period. The recommended cycle period should be no less than 50 milliseconds. If a 10 microsecond with trigger pulse is sent to the signal pin, then the ultrasonic module will output 840 kHz ultrasonic signal and detects the echo back. The measured distance is proportional to the echo pulse width and can be calculated by the formula test distance is equals to high level time into velocity of sound divided by 2. If no obstacle is detected, in that case the output pin will give a 38 millisecond high level signal. So here the microcontroller is using the port C pin to actually read the signal and transmit the signal, and we are using the timer here in the 80 mega 8 to calculate the time between the receiving and sending the signal and calculate internally the distance. So I am going to demonstrate here that how we are measuring the distance with some examples. Here we are placing my hand, actually no other such object is available at now. So here we can see that at ruler the distance is 14 centimeter. Here you can see that is 14 centimeter. Now when I measurement technique with a solid object here, at first I'm going to display the actual distance on a ruler. As you can see, the distance reads 10 cm on the ruler. Now when I place the object quite rightly here on the 10 cm, okay, it took me some time to adjust the scale quite rightly, and now you can see the sensor reads exactly 10 cm. Now when I decrease the distance, decrease the distance, we can see on the display that the distance is minimized to 5 centimeters. Okay, 5 centimeters. Now it's quite stable. Now when I again increase the distance from 10 cm to a point here in the 15 cm, you can see the reading is 15 cm also. In this way, we are just measuring the distance using this ultrasonic sound sensor. And here are some limitations to the project. The range limitations of the sensor is from 2 centimeters to 400 centimeters, and there are accuracy limitations up to 3 millimeters. And when we are going over the distance of 400 centimeters or 4 meters, we are not getting the real values there. And the distance that is less than 2 centimeters is also not giving the proper reading.
So in spite of these limitations we have faced in this project is quite inexpensive project, and it's really easy to build, and you can do the project is quite easily. If you try to do it, it just only takes a sensor and a ATmega 8 and a LCD display. So when I suggest this project is quite good and inexpensive and quite reliable also, up to 4 meters, and that's a quite good distance. And for this session I would like to say goodbye everybody and happy doing your project.